In this video, I'll be solving the limit as x approaches 5 of the square root of x minus 1 minus the cube root of x plus 3 all over x squared minus 5x. The first thing to do is to plug in x equals 5. If I plug in x equals 5, I get 0 over 0. So I'm going to multiply the top and the bottom by the conjugate of the numerator. The conjugate will be the square root of x minus 1 plus the cube root of x plus 3. When I multiply that by the numerator, I get negative 1 plus x minus x plus 3 raised to the 2/3 power. The x squared minus 5x will factor into x times x minus 5. It is clear that if I plug in x equals 5, the x minus 5 term makes the denominator equal to 0. So I'm going to break this up into two separate limits, one of them having the denominator of x and square root of x minus 1 plus a cube root of x plus 3, and the other limit will have the rest. It is important to group negative 1 plus x minus x plus 3 raised to the 2/3 power with x minus 5 because x minus 5 is going to get canceled eventually. Focusing on the first limit, if I plug in x equals 5, I get 1 over 20. And I'll multiply that by the second limit. Now the second limit, when I plug in x equals 5, I get 0 over 0. So I want to multiply it by something. A nice trick is to think of this problem in terms of a cubed minus b cubed. We know that a cubed minus b cubed is a minus b times a squared plus ab plus b squared. Negative 1 plus x minus x plus 3 raised to the 2/3 power is going to play the role of a minus b, where a is negative 1 plus x and b is x plus 3 raised to 2/3. So I'm going to multiply top and bottom by a squared plus ab plus b squared. When I do that, I get the a cubed minus b cubed. Again, where a was negative 1 plus x, b was x plus 3 raised to 2/3 power. When I expand it and simplify, I get x cubed minus 4x squared minus 3x minus 10. Next step is to factor out the x cubed minus 4x squared minus 3x minus 10. And we can factor that into x minus 5 times x squared plus x plus 2. Now the numerator and the denominator have the same term of x minus 5. So we're going to cancel that out, and we're going to be left with a nice limit to solve. I can finally plug in x equals 5 and get negative 2/3, and I'm going to multiply that by 1 over 20. And my final answer is going to be negative 1 over 30.